the revolutionary automobile that brought four-wheel drive out of the woods and into the suburbs. The flight of the 1980 Eagle ushered in a new era in four-wheel drive technology, an era in which four-wheel drive convenience and safety will coexist with comfort and fuel economy in a new generation of American Motors vehicles. The Eagle featured two major design innovations. First, a new transfer case. The model NP119 provided full-time, single-speed four-wheel drive. The new transfer case drove the front wheels through a unique new axle, the Model 30, which was incorporated into the Eagle's independent front suspension design. A viscous coupling positioned in the transfer case served as a limited slip differential between the two driving axles. This coupling gave the 119 the ability to divide drive power between the axles with an efficiency and smoothness that was unparalleled anywhere in the industry. The Model 998 Torque Command transmission rounded out the Eagle design concept by providing drivers with a completely automatic four-wheel drive automobile. Later, a four-speed manual transmission was added. Two in-dealership training films covering the Eagle and its design innovations were mailed to your dealership in 1980. The Eagle chassis film explains all of the suspension and drivetrain components in detail. The 119 transfer case was covered in more detail in the training film entitled The 119 and 219 Full-Time Transfer Cases. If you haven't already done so, review each of these training films before you view the rest of this film. The subject of this film is the Eagle's latest design innovation, the Select Drive system. The Select Drive system, which is optional on Eagle models, allows the driver to operate the vehicle in four-wheel or two-wheel drive. The four-wheel drive mode provides maximum traction in on- or off-road situations, while the two-wheel drive mode maximizes fuel economy in situations that don't require four-wheel drive, such as highway driving on dry pavement. In keeping with the Eagle's other driver convenience features, the Select Drive system is easy to operate. This dash-mounted switch is the only control that the driver is required to operate when shifting between two- and four-wheel drive. There are no transfer case levers that must be shifted. Also, the driver doesn't have to leave the vehicle to lock or unlock any axle hubs. In our discussion of the Select Drive system, we'll look at design and operational information. Then we'll run through a couple of test procedures that will help you diagnose Select Drive performance problems. All of the information in this film is based on this supplement to your 1981 AMC Technical Service Manual, which is entitled Eagle Select Drive. You should have copies of this supplement in your dealership by now. This supplement is your most comprehensive source of Select Drive service information, so be sure to make use of it whenever you service a Select Drive system. Eagles equipped with Select Drive feature these modifications: a modified transfer case, a modified Model 30 front axle, and the addition of a vacuum control system. The transfer case is simply a modified version of the 119. This new case is designated the NP129. Externally, both cases appear to be almost identical. However, there is an important difference. If you're familiar with the 119, then you understand the relationship of these components: the main shaft gear, spline gear, sprocket carrier, and drive sprocket. The 119 also features a shift rail, mode fork, and clutch sleeve, but the mode fork is not attached to the shift rail. At the factory, the clutch sleeve is positioned over the spline gear and sprocket carrier, so both drive axles are always engaged. In the 129 case, the mode fork is attached to the shift rail by a pin. Also, a range selector is attached to the shift rail. The range selector's lever is connected to a vacuum motor by a mechanical linkage. In its four-wheel drive mode, the 129's clutch sleeve is positioned over the spline gear and sprocket carrier, as is the 119's. But when the driver shifts to two-wheel drive, the vacuum motor is energized and the range selector moves the shift rail, mode fork, and clutch sleeve into this position. Now the clutch sleeve is positioned over the main shaft and spline gears. No drive power is passed to the drive sprocket, so the front wheels aren't driven. At the beginning of this film, we identified the purpose of the Select Drive system: to offer improved fuel economy by providing a two-wheel drive mode. So far, we've seen how the new transfer case shifts into two-wheel drive operation. However, the transfer case shift alone would not improve fuel economy. If the Select Drive system were to utilize a conventional front axle, like the one shown here, the heavy ring and pinion gear as well as the front prop shaft would continue to rotate. These components would be driven by the front wheels. As mentioned earlier, though, Eagles equipped with Select Drive use a modified Model 30 axle. This axle uses the same center section and left-hand axle shaft used in Eagles not equipped with Select Drive. But the right-hand axle shaft tube is attached to the shifting mechanism that provides the axle disconnect feature. This shift mechanism is operated by a vacuum shift motor. The right-hand axle shaft actually consists of two individual shafts: an outer flanged shaft and an intermediate shaft. Both shafts are splined at their adjoining ends. A shift collar connects the shafts in the four-wheel drive mode. The shift motor repositions the collar when the driver selects two-wheel drive. When vacuum is applied to the shift motor diaphragm, the shift collar moves inward and is no longer engaged with the outer shaft. The right front wheel now freewheels. When the right wheel is disconnected, only the components identified here rotate. These rotating components don't consume much fuel. What's important here is that the heavy ring and pinion gears, as well as the prop shaft, do not rotate. So far, we've seen that the transfer case and front axle shift mechanisms are both vacuum operated. Let's take a closer look at the vacuum control system. The vacuum system is comprised of four individual components: a vacuum storage canister, the dash switch, the transfer case shift motor, and the axle shift motor. When the vehicle is shifted from one range to the other, the driver must first place the transmission in neutral. Operation of the Select Drive control switch was deliberately designed to require two hands. This requires that the driver bring the vehicle to a rolling stop before the mode shift is made. In order to move the Select Drive control switch lever, the driver must hold a spring-loaded lock pin in its unlock position. The vehicle must be in slight motion to allow the transfer case clutch sleeve and the axle shift collar to perform their shifts smoothly. Here, the driver has just moved the switch lever from its two-wheel drive position to four-wheel drive. The switch now allows a vacuum signal to pass from the storage canister to the axle shift motor. The vacuum signal acts on a diaphragm in the shift motor. The diaphragm moves in response to the vacuum signal, moving the shift fork with it. The shift collar now couples both axle shafts together. When the axle shift is complete, a vacuum port to the transfer case is uncovered. The vacuum signal is then passed to the transfer case shift motor. The vacuum signal acts on a diaphragm in the transfer case shift motor. As a result, the range selector shifts the shift rail and attached fork along with the clutch sleeve. The sleeve moves off of the main shaft gear and couples the spline gear to the sprocket carrier. The vehicle is now in four-wheel drive. Let's look at the vacuum system's operation when the driver moves the lever from its four-wheel drive to two-wheel drive. A couple of things happen. First, the dash switch vents the vacuum from both shift motors to atmosphere. At the same time, the switch reroutes the vacuum signal to the transfer case vacuum motor. This vacuum is applied to the rear vacuum chamber. As a result, the clutch sleeve now releases the sprocket carrier and the case is back in two-wheel drive. When the transfer case shift is complete, a vacuum port to the axle shift mechanism is uncovered. The vacuum signal is then passed to the axle shift motor. The vacuum signal pulls the axle shift motor diaphragm into this position, uncoupling the axle shafts in the process. The vehicle is now operating in two-wheel drive. The vacuum system components are connected by a series of vacuum hose harnesses. These are molded to make installation foolproof. As we've seen, the Select Drive system was designed with simplicity in terms of design and serviceability. There are a few service procedures you should be familiar with. An important point regarding front axle service pertains to the axle's lubrication requirements. The axle housing and the shift mechanism housing each have their own reservoirs. Be sure to keep this in mind whenever you have occasion to check and fill either one. Here's another important axle service tip. The axle shift motor has a small vent located just ahead of the vacuum passage to the transfer case. If the vacuum seals fail, the vent prevents the axle oil from being sucked up by the engine vacuum. So keep in mind that oil around this vent area indicates a shift motor problem. There are two tests that are particularly valuable when diagnosing a Select Drive malfunction: the transfer case shift motor function test and the axle shift motor function test. To perform the transfer case test, begin by disconnecting the vacuum harness from the transfer case shift motor. For photographic purposes, we've removed the transmission crossmember and transfer case skid plate. Then connect a vacuum pump to the shift motor's front port and apply 15 inches of vacuum to the shift motor. Rotate the rear prop shaft to fully engage the transfer case in four-wheel drive. The shift motor should maintain vacuum to the front port for at least 30 seconds. If the shift motor does not maintain vacuum, replace the motor. If the motor does maintain vacuum, disconnect the pump and reconnect it to the rear port. Plug the front axle connecting port and again apply 15 inches of vacuum to the motor. If the Eagle you're servicing has an automatic transmission, shift it into park. For manuals, place the transmission in first gear. Again, the shift motor should maintain vacuum for 30 seconds. If the shift motor fails to maintain vacuum, replace the motor. If the motor does maintain vacuum, continue testing. Rotate the prop shaft to ensure a complete transfer case engagement and remove the plug from the front axle connecting port. You should hear a hiss indicating that vacuum is present. If this is the case, neither the shift motor nor the transfer case is the problem source, and you should proceed to the axle shift motor test, which we'll cover in a moment. However, if vacuum is not present at the connecting port, slide the boot away from the shift motor stem and measure the distance the stem has extended. This distance should be at least 5/8 of an inch from the edge of the shift motor housing to the E-clip on the stem. If this is the case, replace the shift motor. If the distance is too short, an internal problem in the transfer case is preventing the stem from extending. The steps for performing the front axle shift motor test are similar to those for the transfer case test. First, disconnect the vacuum harness from the front axle shift motor and connect the vacuum pump to the front port. Apply 15 inches of vacuum to the shift motor. Rotate the right front wheel to fully disengage the axle. The shift motor should maintain vacuum to the front port for at least 30 seconds. If the motor does not maintain vacuum, replace the motor. If the motor does maintain vacuum, disconnect the pump and reconnect it to the rear port. Plug the transfer case connecting port and again apply 15 inches of vacuum to the motor. The motor should maintain vacuum for a minimum of 30 seconds. If the shift motor does not maintain vacuum, replace the motor. If the motor does maintain vacuum, remove the plug from the transfer case connecting port and check for vacuum. If there's no vacuum present, rotate the right front wheel to ensure that the axle has shifted completely. Check for vacuum at the connecting port again. If vacuum is still not present, replace the shift motor. If vacuum is present during this check, the shift motor isn't defective. The problem source may be in the vacuum control system. Consult the Eagle supplement for further testing procedures. Both of the shift motor function tests are also detailed in the pocket-size reference book that's included in this training kit. Well, that's it. As we've seen, the Select Drive system is a simple one in terms of driver operation and service requirements. Equipped with the information contained in this training kit and in the Technical Service Manual supplement, you should find Select Drive service to be a snap.